Today we'll do significant figures and scientific notation. So what are significant figures? These are the description in front of you. These are the rules, so you need to remember these rules. So what are significant figures? Any digits that are non-zero are significant. So in this case, 91 got 2 significant digits because both are non-zero. This has got 5 significant digits. Right. Zeros appearing anywhere between 2 non-zero digits are significant. So this one has got 5 significant digits because that 0 in between the 2 ones are significant. Okay. However, leading zeros are not significant. So in the case where the zeros in front of the number, they are not counted as significant. This will only have 2 significant figures. Okay. So not all zeros are significant. When zeros are in front of the number, they are not significant. Trailing zeros in a number containing decimal point are significant. So you see that 0 at the end, because it's after the decimal point, are significant because it's after the digits. Whereas here, this is not significant, even though you have a decimal point. If you look at this one, has got 6 significant digits. These are significant. But these ones in front of the number are not. So that's got 6. Well, if you write it, it's counted significant. If you don't write it, it's not significant. So there will be infinite 0, but if you write it, means there's 1, 2, 3, 4, 5, 6. That's where it stops because you stop writing. But if you write more, you'll have more significant figures. Yeah. Because it's more accurate, means that I'm certain that these 2 are 0. Whereas, so if I got 0.12, 0.120, this is more accurate. Because when you do 0.12, it could be rounded from 0.121. If you round it, it becomes 0.12. Whereas if I write that, I have more information that I know that has to be 0. Whereas this one, it could be 1, could be 2. We don't know. So that's why. So the more significant figures it has, the more accurate it is. Yeah. Even though these 2 seems to be equivalent, but in terms of accuracy, this gives us more certainty that this has to be 0. Whereas this can be anything. We don't know. Okay. All right, good. Next one, this has got 5 significant digits because the 0 at the end after the points are counted as significant. So there are 5 significant digits. However, if the 0 are in front of the dot, these are not counted as significant, so that only got 2 significant figures. So it can be a bit confusing. Okay? Let's do some examples. Let's do the first one. It asks you how many significant figures does each number have. So let's count. 1, 2, 3, 4, 5, 6. So 6 significant figures. Okay? That 0 is counted. All right, next one. How many significant figures does the next one have? Again, that 0 is in between. It's counted, so it's 5 significant figures. Let me ask a student. Julia, how many significant figures does this have? 3. Yes, we do not count the zeros. Okay, so we write 3 significant figures. Right, next one. Catriona, D. How many significant? 3 significant, yes, because we don't count these, so we can only get 3. Done. Now we need to know how to round to the certain number of significant figures. Okay, these are different from rounding to a certain number of decimal places. So that's say 1 significant figure. The first one is 2. So what you do is you're going to write. So these will have to be changed to 0. Because it's less than 5, you become 200. So round to 200. So that digit, because that 1 is less than 5, you don't round up. So you just keep it at 200. All right, next question. 2 significant figures. So this is the first, this is the second. And you look at the digits after the 6. In this case, it's 7. You're going to add 1 to the 6. So the answer will be 2, 7. The rest become 0. So 5 zeros. So the answer becomes 2,700,000. Correct to 2 significant figures. Okay. Alright, next one, 3 significant figures. So you count this as your first, second, third. You have to add 1. So you go 0.000188. Now do not put 0 here because that will be 4 significant figures, isn't it? So do not put 0 after the decimal point. So it will be just 0.000188. Okay. Alright, next one, 2 significant. So you go 1 and 2, so you get 1.2. That's it. Any question? Pretty easy. Alright. Once you know how to round to a certain number of significant figures, we can then, yeah, you can't put the 0. If you put 0, that will see this will be 4 if I put the 0. So do not put 0. But you have to put 0 here. Otherwise it becomes a different number. 27 is wrong. Yeah. Okay, just be careful. Alright. Good. Alright, let's continue. Scientific notation. So write this as a number. So 10 to the power 5. Just move the decimal point 5 places to the right. 1, 2, 3, 4, 5. So 4 zeros. What if you want to do it on a calculator? You could do so by pressing 3.5. Notice that there's a times 10. Just press that. Press 5. I'll give you this. Okay? Now this is different from writing 3.5 times 10 to the power of 5. Can you see that I have to press more buttons to get to the power 5? So this could be quicker. So do 3.5, this button, 5. Do not put power there. That will be wrong. So it gives you error if you put a power. So get rid of the power. Just put 5 next to it. Gives you the answer. Okay? Alright. Next one, just move the decimal place twice to the right. So you get 451. And if it's negative, you go to the left. So you go 1, 2, 3. 0.00674. Any question? Alright. Next, we're going to write in scientific notation. That's good. Alright, scientific notation. So how do you write in scientific notation? You put a dot after the first significant digit. So 3.7 times. And then you count how many digits after this 3. 1, 2, 3, 4, 5. So put 5 here. Okay, pretty easy. Alright, try the next one. Equal. So you just put a dot after the 1, so 1.2, but you have to include all the digits. And then you write times 10 to the power of, count the number of digits, there are 5 digits. So you put 5. Okay? Notice that I don't write the 0 after the 7, but this one I do write the zeros. I do have to write all the digits because they are significant digits, but this one you just write 3.7. Okay? You don't need to write the zeros at the end. Alright, we've got some small numbers, so small numbers are also easy. Just go put the dot after the first significant digits, which is 3, so write 3.7 times 10. And what you do is just count the number of 0. 1, 2, 3, 4, 5. So you go negative 5. Because it's at the front, you write negative 5. This one you can't count the number 0, you count the number of digits after the numbers. This one you count the number of 0 or number of digits after the first significant figures. Alright, and then we'll do the one more. This is 6.751. Just count how many digits in front. 1, 2, 3, 4. So it'll be negative 4 is your final answer. Question. Yep. Oh. Get a mistake, should be 4. Yep. Sorry. Okay, should be 4. Let me rub this off. Yeah, 4, because there are 4 digits after 1. So 1, 2, 3, 4. So it's 4. Okay. Alright, now we have to do something new. This is scientific notation and significant figures. We have to do something new. This is not taught in year 10, so this is new to you. So pay more attention. If you Alright, go to next page. Alright, absolute value. It's actually quite easy. Let's look at this together. Quite easy. Alright, let's look at this. The absolute value of a number is the distance of the number from the origin. It is also called the magnitude of the number. So, for example, the first one is 3, and the symbol for absolute value is this double line. It's like a bracket, but except it's vertical. This means the absolute value. And the absolute value of 3 is 3 because the distance from the origin is 3, right? And the absolute value of -5 is 5 because the distance is 5. The distance is positive. Now, is there a button on that on a calculator? Yes, there is. Now you know what ABS stands for. It means absolute value. So if I press absolute value, 3 gives you 3. If you absolute value -5, it will give you +5. So ABS means absolute value. Now you know what it means. Okay. All right, now C. Next one. Absolute value -0.8. All you have to do is just change the negative to positive. You don't even need to draw a number line. So negative becomes positive, positive stays as positive. Now we can do this question. Again, you can do it on a calculator or you can do it by hand. So every time you see absolute value, 3 plus 5 minus 4. You still have to minus 4 because it's outside the absolute value. You subtract 4 and the answer will be 8 minus 4 is 4. Okay? Or you can type the whole thing on a calculator if you want to, but I think it's faster without a calculator. Let's try that. ABS, -3. And then you go out, plus. Can you see it takes a long time if you do it with a calculator? You have to do the arrow. If it's an easy question, you can just do it by hand. I think it's quicker. ABS again, 4. Should give you 4. Okay? Alright, cool. How about the next one? Next one may be good to do on a calculator, but let's do it without a calculator. 2 times, now that's -4 to the power of 3. Now I need to know the order of operation. You still have to do what's inside the absolute value first. It's a bit like bracket. Times by, this is -3 squared. Now the next one will be 2 times +4 because the absolute value goes first before you cube it. Plus 5 times +3 squared. And then you do on a calculator. Okay? Let me see, where's my calculator? Okay, so you go 2, 4 cubed, like this, plus 5 times 9 equal 173. Okay, all done. Any question? So absolute value so far pretty easy, even though something you haven't learned, but it's not hard to learn. Okay? All done. Okay, now we have to do the next problem. We have to show this rule is true by using these numbers. Let's see whether it works. So when you show something is true, you have to go use the left and the right side because this has the left side called the LHS. Okay. Oops. Control Z. Okay. So left hand side is absolute value of A plus B. Let's do A plus B using these numbers, which is absolute value of -2 plus 3. -2 plus 3, and that becomes +1, isn't it? On the other hand, the right hand side, you go absolute value of A plus the absolute value of B. That becomes absolute value -2 plus absolute value of +3. And you absolute value them before you add them, so that will result you in a bigger number, isn't it? 5. So therefore, this inequality upholds, so therefore we have established the left is indeed less than the right. Oops. Right. Okay, so that's how you show something. So when they ask you to show this is true, you got to show the left and right are true. Okay? Any question? Alright, okay, cool. Let's do, now the next bit is going to be a little bit more abstract, so pay very careful attention. Right, so now we know how to do calculation of absolute value. They are very easy. You just have to change negative to a positive. We're now going to look at an algebraic definition of absolute value. How do we explain it using algebra? when we do absolute value. That's what we're going to do. Okay, let's have a look. So this is absolute value of A. It has two possibilities because it's just equal to itself if it's positive. It's equal to the negative of itself if it's negative. Let's examine how this works. Okay, so absolute value of 3. It's going to be equal to 3 because 3 is positive, right? Right, we use this. Because 3 is positive, it's equal to A itself. So we use this rule. Absolute value A equal to A, just equal to itself. Right? So when 3 is positive, I use the first rule. So there's two options. There's option 1 and there's option 2. It tells you which option to use, depends on which one is true. Okay? Now how about the next one? What if I need to do absolute value of negative 3? Well, we use the second one because negative 3 is negative. We use the second rule, which is absolute value of A equal to the negative A. So we're going to put a negative in front of negative 3. And why do I put a negative in front of negative 3? What does it do? It turns it into positive. That's what it means. So that rule is to turn things into positive, to turn a negative into positive, is just simply put a negative sign in front. That's the algebraic definition. Alright, so you need to be able to write things this way. So in the next few examples, we're going to practice writing this definition. Okay? Absolute value A being having two options. A if it's positive, negative A if A is negative. Alright, so to turn a negative number to a positive number, we'll just put a negative sign in front of that number. This is what we did. Put a negative sign in front of that number, that will turn it into positive. Alright, on the next few pages, we're going to do some example of that. Pay very careful attention because they can get a bit abstract. Next page. We're going to write expressions. So in the homework, in the textbook, they ask you to write expressions for absolute value of x without the absolute value sign. Okay? So let's do the case 1. Case 1 is if x is positive or bigger than or equal to 0, x is positive, we're going to write absolute value x equals to x, right? So if x is positive, it's just equal to itself, you don't do anything to it. That's case 1. Case 2, what if x is negative? What do we do? Negative. Well, if it's negative, you just write absolute value x is negative x. That's it. So it's pretty easy. So basically, you can summarize this into here. Absolute value x equal, curly bracket, x, if, that's a short way, if x is positive, or negative x if x is negative. So that's the definition of absolute value x. Basically a formula. So it gives you a formula on how to calculate the absolute value of that polynomial. And it explains when to use which formula, whether to use x or use negative x, depending on the value of x. Alright, the next two will be a little bit different. So remember this rule, because we're going to use this rule again, having two cases. Let's look at a simple one. Let's look at this one. Okay. You say write expressions. Now this is a different expression now. Absolute value x minus 2 without the absolute value sign. Alright, let's do the two cases. We're going to write absolute value of x, this thing, is equal to itself, isn't it? Right? Because whatever is inside the absolute value, you just take it out as long as this is positive. So we've got to be flexible because this is not the same thing as x as before. It's absolute value of x minus 2. So obviously things have to change a little bit. So the absolute value of x minus 2 is same as x minus 2 if whatever is inside x minus 2 is positive. Yeah, bigger than or equal. So when we say positive, we make it include the 0 as well. Or put it simply, it's not really positive, we just call it non-negative. Because 0 is not really positive. We'll just say this is non-negative. Okay. Now, because it's x minus 2 bigger than 0, let's make x a subject. So that will become more specific. If x is bigger than 2, we can use this rule. Okay? When x is more than 2. On the other hand, this is going to be the negative of itself. Notice I use a bracket because there's more than one term. Negative of itself if whatever's inside is negative, which you have to solve. So when x is less than 2, we use the second option, right? So when x is less than 2, we use this option. Well, so we can summarize it on the right. We get absolute value of this equal to two options, equal to x minus 2 or the negative of x minus 2, depending on the value of x. So if x is bigger than 2, not positive now, bigger than 2, or if x is less than 2 for the other option. So study this very carefully. It looks exactly same as above, except there are slight changes because the expression changed. Right? X minus 2, if x bigger than 2, etc. And then we've got to do one more, and then we're done. So this part can get a bit abstract, but just pay careful attention to what to write in each step. All right? Yes? Yeah. That means, see, this has been written without the absolute. See, there's no absolute value sign here. I've converted this to this. So, yeah. So, yes. So, what you need to do, so, say, for example, if I want to substitute x equal to 3, I'll just substitute into the first option because x3 is bigger than 2, right? So, write 3 minus 2 equal to 1. Or if I substitute x equal to 1, I use the second rule because when x is less than 2, I use the second. Negative 1 minus 2, that turns it into positive 1. Yeah? Okay. We'll do the next one. Okay, so that's, I would say, the most challenging part of this chapter, absolute value, because it's a big challenging. Let's do one more. Let's do it slowly again. Absolute value of 2x minus 4. Oh, let me rub this off. Okay, absolute value. This pen sometimes doesn't work very well. Let me do that again. Okay, absolute value of 2x minus 4. That equals itself as long as if 2x minus 4 is bigger than 0. Exactly the same working as before, except the expression change a little bit. And when you have an x that's not the subject, you have to solve for x. So if this is positive, means if 2x is bigger than 4, adding 4 to both sides, if x is bigger than 2. So we can see if x is more than 2, I could use this formula. And then we have to use the second bit, the second case. This is equal to the negative of itself. And when do we use the negative of itself? If whatever's inside is negative. And like before, you have to solve for x. 2x is less than 4, x is less than 2. So we have to divide it into two cases. So I could summarize this on the next bit. So you write 2x minus 4 equal curly brackets because there are two options. The first option is this, as long as x is more than 2. Ran out of space. Maybe I'll write it below. Okay, I'll write it below. So absolute value of 2x minus 4 equals to two cases. 2x minus 4 if x is positive, bigger than, if x is more than 2. And negative of itself if x is less than 2. This is your final answer. So I've written 2x minus 4 in absolute value without an absolute value sign. Okay, any questions? So today you're going to start the exercise. So what you need to do is go to this one here. Make sure you write the date. The date is, which is 5th of February. And there's 2 exercises you have to do. 5th of February, like that, 2 exercises. 1.8, 1.9. That's today. And make sure if you have time to do the test yourself, chapter review, because that's finished. And the challenge exercise if you have time. Yeah. Now, this one, maybe do a few questions from there. It's mostly revision, just do maybe 5 to 10 questions. And the next one, absolute value is new. Maybe you should do at least 10 to 20 questions. And this one, you just do, I think it's a chapter review, so it's good to do most of them. And yeah, just do them as you go and just cross out the one you've done. And if you really want to get band 6, try to do some challenge, okay? Which reminds me, I've got one more thing to say. At the back of your notes, there is this past HSC question, so you could try some in your book. Answers at the bottom, don't look at them yet. Mark it after you finish, okay? Yeah, that's it. That's done, so make sure you can start now. If you have questions for homework, let me know. All right, let me close.